All right, sounds great. Welcome everybody to our first STTM workshop about the sdtm.oak package. To introduce myself, I am Rammprasad Ganapathy. You can call me Ram. I am part of Roche Genentech. I have been with Genentech for like 7 years now as a principal statistical programmer, or the new title is the principal data scientist. So we have been working internally to develop the R packages for STTM creation in Roche for the last few years. Me and my team, we developed that package from proof of concept to full production implementation. So now we have over 50 studies using the internal package for regulatory reporting work in Roche. And inspired by Admiral, we wanted to bring the package as an open source as well. So then we started working with the community to develop the sdtm.oak package. And like a couple of months before, we had our first CRAN release version 0.1. And this workshop is to showcase what you can do with the sdtm.oak R package. Right, so I'll go to the next slide. So what are we planning to do today? By the end of this workshop, so you will have the updated code for STTM, CM, and vital signs domain using the sdtm.oak R package. And you should have gained an understanding of how to use the sdtm.oak package. And also you should have an understanding of how to use the resources that are available in the package to build STTM in R. So we have some assumptions about people who are attending this workshop. So the basic knowledge of CDISC standards is mandatory. So we assume that you already know about STTM and its concepts, and you have some prior experience in programming STTM domains. And the basic background of installing R packages and R and its packages, and then basic familiarity with the RStudio IDE that you will be using today. And then you have understanding of chaining the functions together to creating an output. And the agenda here is today, so all times are in Eastern Standard Time. I am in Pacific Time. I know people are in various time zones. I am just while we are setting up the session, I'll fix this. So the agenda is we will first spend the first 10 to 15 minutes in setting up the workspace, and then we'll go through some theory session of 15 minutes about. All right, back again to the agenda. So the third time should work. So we'll first spend the 10 minutes setting up the workspace, and then following that, I'll give a presentation about the introduction to sdtm.work package. And then we will spend like 35 minutes doing the programming for converts domain. I'll walk you through the code, execute step by step, and then you can follow along. And then we'll have a break for some time, and then probably break for 10 minutes. And then we will start with the vital signs domain programming. That will go for some time. We follow the same approach, execute it like step by step, and you guys can follow along. And then that will be the end of the workshop. So we'll first start with the 10 minutes of the setting up workspace. So while you are setting up the workspace, I'll probably like make sure that my cloud is also working fine. And while everybody is setting up the workspace, probably I'll go through the next few slides. So today I'll be the main presenter. I'll be presenting, running through all the slides and running through the exercises and everything. And we have two more people from the sdtm.org package who are going to help us. So Edgar and Shiyu are available on the chat spaces to help. So they will help you answer any questions related to the sdtm.org package, and the POSIT team will take care of the rest of the questions about access issues to POSIT Cloud and setting it up and getting you up to speed. And setting up your workspaces to code. So the preferred method is to use the free POSIT account. And I see that Phil has already started posting the messages in the chat. Thank you, Phil. And So the package already has the workspace already has everything. If you see here, like, so the datasets folder have all the datasets, the raw datasets that are needed for us to do STTM today. And the exercises folder has the code that we will be running with you today. And the specs folder has the annotated ECRFs about the two domains that we are going to do, conmets and vital signs. So either you can grab the files from repo if your POSIT account is not working, and I have the link to the repo here. If anyone has problems, let us know. We can post the link to the repo in the chat, and like once you can copy the files, you will be able to follow along. Or like you can clone the repository yourself if you have the SHS key, SSH keys, and everything set up for the GitHub. You can clone the repository and follow along. Or you can sit back and relax, and that will be still worthwhile to watch what we do, and you can get a very good understanding of the sdtm.oak package, guys. So we will first start our 15 minutes going through the basic concepts of the sdtm.oak package before we jump into the coding session. So about this package, okay, so this started as a collaborative effort between like CDISC COSA. So COSA stands for CDISC Open Source Alliance, and like several pharmaceutical companies were involved since the beginning, like Roche, Pfizer, GSK, Vertex, Arcturus Research, Pattern Institute, and Transition Technology Sciences. So all of them contributed to the development of this package. And this is part of the Pharma group of packages. So it was officially accepted like a couple of weeks before, and it is available in the Pharmaverse. And I also wrote a blog about this package last week, and the blog post was published in the Pharmaverse blogs. And the basic inspiration is from the Roche's RWork package that we use internally for mapping the raw data to STTM. So we were not able to outsource the RWork package because that was built for Roche. So we got inspiration from that, and we had to redevelop the package so that it can be used across multiple companies. So if you see the Pharma suite of packages, we have like amazing packages to handle the ADAM datasets creation, TLGs, and e-submission. And there was a critical gap until now. That is like there was no package that was not in Pharmaverse to handle the STTM creation, and STTM.work package fills this critical gap. So with the release of this package, now the users have R packages to support their end-to-end statistical programming needs from STTM all the way until e-submission. So let's start with like what are the challenges in the STTM programming. So we all know that like STTM is simpler. It is not as complex as Adam, meaning it does not have that complex derivations like what we have in Adam, but it has a different set of challenges. So the Adam datasets has a well-defined input source, that is STTM, but for STTM we do not have that flexibility. The STTM's input dataset is the collected data in a clinical trial that comes from the ECRF or the external data sources that can be in wide varying format. So that overcoming that challenge was like very important when we go as an open source, because the companies build STTM solutions to suit their EDC system and how they receive the data. So the solution that works for one company will not work for another company because they will have a different input raw data structure. So when we build an open source solution, so we have to build it in a way that we are able to support the EDC, that we are able to support the data that we get from the different EDC systems, like different variable names, dataset names, and everything. So even if you take the same standard ECRF and you build that in different EDC system and you extract the data from it, you will see that the data is different from each of the EDC system. So developing one solution that fits all was quite challenging in the first place. And the second challenge is, like the varying data collection standards. So although CDAS is available from CDISC, it is not mandated by FDA. And like different companies have their own data collection standards. For instance, at Roche, we do not follow CDAS standards. So we have the Roche proprietary standards. And like there are like many companies that have their standards like Roche, and also there are many companies that follow CDAS standards for collecting data. So the two things like makes it very challenging for to create a solution that can be that can be EDC agnostic and data standards agnostic, that can be used by wide variety of vendors, wide variety of users across like hundreds of EDC system and external data sources. So in the version 0.1.0, so we have tried to address that, and it's available on CRAN now. And we have designed highly versatile functions that can accommodate varying raw data structures from different EDC systems and different external vendors. So we are calling sdtm.oak as an EDC agnostic solution. And also, it does not rely on any specific data standards. It should be able to accommodate the CDAS standards or any proprietary data collection standards defined by pharmaceutical companies. So even today in our workshop, we are going to look at two domains: Conmeds domain that follows the CDAS data collection standards, and the vital signs domains that does not follow the CDAS data collection standards. That can be like something else. It's not just CDAS. And it provides a framework for modular programming, very similar to what we have in Admiral. So that makes it like a valuable addition to the Pharmaverse ecosystem. So another important thing that we need to understand is about the algorithm. So from Roche, within Roche, we created these algorithms, and actually we have open sourced these algorithms and redeveloped the code for these algorithms. So in the next few minutes, we will look what these algorithms are. It's not complex, it's very simple. You will understand as we go through it. So the key concepts are, like the STTM mappings that from that map the raw data sets into the target STTM model are grouped into the common logics. So instead of grouping it by domain, so we have grouped it based on the logic of what is used for the STTM mapping. So these mappings from the backbone of the sdtm.oak package. So the algorithms can be reused across multiple STTM domains because we have grouped it based on the logic that we apply for the mapping, not based on the domains. And technically, these algorithms are programming language agnostic. So we have implemented this in R. But if someone wants to do that in Python, they can take the same algorithms and create an sdtm.oak Python package. So within the sdtm.oak package, we have one R function. I mean, not one, like we have like R functions to for each algorithm, but there is one user-facing R function to represent each of these algorithms. So let's start with the simplest of all algorithm, assign no CT. Assign no CT is A equals B. Okay, so it's like one-to-one mapping between the raw source to the target STTM domain without applying any control terminology. So a couple of examples could be MH term and AE term. So MH term and AE term, we usually map what is collected in the raw source without making any changes. So it's just A equals B. The second algorithm to do that is the assign control terminology. So that's the one-to-one mapping between the raw source to the target STTM variable. And on top of that, you need to apply a control terminology. So when you collect the data, so the collected data can be in multiple different formats. But when you create the STTM domain, it has to use the submission value as defined in the CDISC control terminology. So the assign control terminology function takes the collected value and it looks up the control terminology for your study, and it maps it to the standard value as defined by CDISC. Couple of examples can be, like position and laterality in the vital signs domain. And the third algorithm is like assign datetime. So this assign datetime can be applied across all domains where you want to map the raw date to an ISO 8601 format in any STTM domain. It can handle many types of date formats, and also it can handle date and time. and also it can handle the unknown components. Okay, so if you have like one raw date that has both date and time in it, or two columns that represents date and time in your raw data, this function can this algorithm and function can still handle it and create your ISO 8601 format date. And the next algorithm that we need to know is the hard code CT. So in many cases, like you may not collect all the data explicitly on the ECRF. Like for example, when you are collecting systolic blood pressure, there may not be an additional data collection field to collect the unit for the systolic blood pressure. The unit might be hard coded on the ECRF, right? MM and HG, and that will let the sites know that they have to enter the data in MMHG format. So in those such cases, like you have to hard code the unit for the original result, right? And so in such cases where you want to hard code a value and apply a control terminology, so we use that function hard code control terminology. And hardcode no CT is where like where you are hard coding a value that is not collected on the ECRF, but there is no control terminology associated with it. So in some cases, like you may even have need to hard code the topic variable to some value, or you may have a category or subcategory to hard code to be hard coded to one value. So in all these scenarios, hard code no CT algorithm can be used. And the last one in our list is the condition add. So in many cases, like we need to apply a condition when before mapping a qualifier. Like for example, in this example, in the two examples that we have. So if MD prior equals 1, then cm.cm str tpt equals before. So if the collected value is 1, then you are populating the target value as before. So you are doing this you are doing like a condition at the source before applying before mapping a target STTM variable. The second example, like you want to map the VS method only when your VS test code is temperature. So because that method oral, it could be something like that, right? It's applicable only for the test code temperature. It is not applicable to systolic blood pressure or diastolic blood pressure, right? So now you are applying a condition based on the target STTM variable. So the condition add algorithm can be used to achieve such scenarios where you want to map something um, based on a specific condition, and this can be interchangeably used with all the 5 algorithms that we saw before, like assign CT, assign no CT, hard code no CT, and assign datetime. All 5 algorithms can accept condition add as a parameter, and it can filter for that condition, and it can perform the mapping. So we will go through this in detail when we like when we do our exercises. All right, so now that we have seen our like 5 basic algorithms. Okay, I have 6 basic algorithms, right? So you can see that the algorithms are grouped by their mapping logic. It is not grouped by the STTM domain. So if you take the assign no CT, the simplest of all algorithm, it can be applied across all different mappings we have in this picture. It can be used for the MH domain, MH term, vital signs, original result, AE term, lab, like substance use, clinical events, exposure, and let's say that you have a non-CDISC variable that follows the same mapping logic. You will still be able to use this algorithm to map that non-CDISC variable or non-standard STTM target variable. So that thus making these algorithms like highly versatile, and like these functions can be used again and again across multiple domains. All right. So now let's see how to use these algorithms and program in sdtm.oak package. So the programming concept is, like it is very close to the key STTM concept that we will go through in the upcoming slide. So it provides a straightforward way to do step-by-step STTM programming in R. That is like mapping topic variable and its qualifiers. And programming steps are generic across all classes of domains like events, interventions, and findings. So this is like a high-level picture of how the STTM concept is laid out, right? So you have, for every record in your STTM domain, in many cases, topic variable is the key. In some of the newer domains, it can be topic variable plus test detail, or topic variable plus object. It could be a combination of few records that define that record in that particular domain, right? So at the end of the day, so like topic variable is at the heart. And then so we add qualifier variables, identifier variables, and timing variables. So these qualifiers, identifiers, and timing variables give additional information about the topic variable. Like MH term, the medical history term, like an identifier variable is like, so okay, so for the subject, now subject ID tells for which subject that medical history has happened, and the timing variable tells when it happened, and the qualifiers gives like additional qualifiers about that MH term or the BS test code that we are collecting. So this is the heart of the STTM concept. And if you see how we program it, for every mapping we do, we will visualize, okay, what is the topic variable and what are its qualifiers, identifiers, and timing. So we'll first map the topic variable, and then we will add qualifiers, identifiers, and timing variable to define that additional concept about the additional details that explains the topic variable. So what are the high level programming steps? So obviously we have to read in our raw data sets. Okay. And then we will learn another new concept called ID vars. Okay. So we will be creating these ID vars in the raw data set. Okay. So we have predefined some of the ID vars, and these ID vars can be extended to add anything else. But today, for the sake of this exercise, we'll keep it simple, and like we will be able to create the domains with the predefined ID vars we have. And an important point is, like, we are creating the ID vars in the raw data set before we starting to process that. Okay. And then a user has to prepare the control terminology for that particular domain, and the control terminology can be fed in to work in the predefined format we have. And just as we saw first, we will start with the topic variable in that raw data set, and we first map the topic variable, and we map the rest of the variables. Okay. And then we repeat the map topic and map rest for every topic variable on that particular data set. For example, in ConMeds domain, that could be only one topic variable collector. But in vital signs, we are collecting multiple topic variables like systolic blood pressure, diastolic blood pressure, pulse, temperature, everything is a topic variable, right? So in CM, we have to do that only once, but in VS, we have to repeat that step several times. So we repeat that step again and again until we finish mapping all the topic variables and its qualifiers. And then we add like the derived variables like use subject ID, study ID, and all those things. Okay. And then we add the labels and attributes, and that's it. So these are all the steps. So, and these programming steps does not change for any domain. So it's the common thing for all the domains. All right. So I think we are ready to start our first workshop about creating the ConMeds domain. Okay. All right. So how we will code today? So I'll walk you through the code of CM and BS and discuss each function and its arguments. And we have a, uh, an occasional check-in poll or some quiz at the end. So yeah, try to move along quickly with me, and I'll go slow, like, because when I am explaining a function, like, and its output, you will have enough time to recreate that. And yeah, please post your questions in the chat. So we have Edgar and Shiu to help answer any questions. And full scripts are available in the exercises folder. So there are no surprises today. It's already pre-programmed. So this is the first workshop. So I did not, I did not want to have like some exercises or something like that. So it's already pre-programmed. So you can read the code, understand it, and execute it along with me, and to get the output. All right. So we'll first review the ACRF for the STTM domain. Okay. So the ACRFs are in your RN Pharma space. In the specs folder. So you have the CM C dash, so you have like multiple files here. So you have the CM underscore C dash ACRF, and this is an Excel format that you can download and you can look at it, or this is in the HTML format. So probably I'll first open this HTML file and show you how it is. And then I'll show the ACRF that explains the mapping. And then we can get on to the code and go through it. Okay. So if you look at the so this is a standard form. Okay. So I took this ECRF, Conmets ECRF from the CDISC ECRF portal, where they have created the standard Conmets ECRF. It's in the CDISC website. You can go and search for CDISC ECRF portal, and then you will land in this page. You can find the Conmets folder. So you can see, like it's a pretty much standard. There is a leading question where there any concomitant is taken, yes or no, and then followed by a bunch of questions. So what was the therapy? What is the indication? What is the dose? What is the unit for the dose? And then what is the frequency? And what is the route? And what is the start date? And is the medication ongoing? If not, what is the end date? So it's a very simple and standard Conmets ECRF. So now if I look at how this ECRF is mapped, I'll show you the annotated ECRF page here. I hope you can see the chat message here. Okay, so all right. So here I see a lot of messages here. I don't think there is any chat messages waiting for me. Right. So I'll showcase, I'll explain this easier. Okay. So I hope everybody can see my PDF. So my first question is, were there any medications taken? The raw data column name is it.cmyn, and I decided not to submit that particular field because there's nothing to map. And what is the topic variable in CM domain? So in CM domain, CMTRT is the topic variable. So that's the first thing that I'm going to map, and it's right here. Okay, so it's a text box where we are collecting the medication or therapy. And then all the other field that we are collecting here gives additional information about the CMTRT. And the next thing is indication, and the indication is mapped to CMINDC and the dose. So dose, I have just added like a little bit complex here. So if it is numeric, then it is mapped to CM dose. If the value is character, then I am mapping it to a different column, CM dose xt, okay, or CM dose txt it should be. Okay. So this will give us an opportunity to use the condition based mapping. Then what is the unit of this dose? And that is mapped to CM dose u. And what is the form of the medication? Okay, that is mapped to CM dose form, and the raw data variable name is it.cm dose form. So if you see here, everything has it.cm dose form, something like that. So that is the CDASC standard format they have in the ECRF portal. So I kind of use that to create some dummy data and stuff. And what is the frequency of that medication? That is mapped to CM dose freq variable in the CM domain. And then the route of the medication is mapped to the CM route. And the start date is mapped to CMSTDTC. And is it ongoing? Okay, so if they choose yes for ongoing, then we are putting the reference end time point as ongoing. And then if yes, then CMENRTPT is date of last assessment. As of the date of last assessment, it is still ongoing. That's what it means. And if it has already ended, then we populate the CM end date. So it's a simple and straightforward mapping here. Okay. So with that, I will move on to my RStudio to read the data and map it. and continue here. I hope you can see my R Studio here. Okay. So the header of the program says, like the program is in projects, exercises, and cm_c dash folder. So this setup file thing is another. You need to install these two packages here. I think if you have used the POSIT Cloud, it comes pre-installed, so you may not have to do it again. But if you are using any other means, then install the sdtm.oak package and the Admiral package. We are just using some utility functions from Admiral, so we are installing that package. Okay, so let me quickly start the programming. And what are my input here? Okay, so my input is my raw data set that is in the C dash format, and my control terminology file that I already have, and my DM domain to map the um, is it the I think it's the study day variables, right? Yeah, study day variables. All right, so I first start by running the library commands where I initiate the libraries. Okay, so you can either choose this and click run, or you can do command enter. Okay, so because I am not using, if I use the keyboard, people will not be able to know what I am doing. So I'm just going to select it on the screen and run it here, so people can follow exactly what code I'm running. Okay, so I have initiated the two libraries, and then I am reading in the study control terminology file. My study control terminology file is in CSV format, that is in the datasets folder. So if you go to projects, datasets, so I have my control terminology DM and the cm.datasets. All these three files are here. Okay, so I'm going to read this particular file, and I have my environment here. You can see it here. So yeah, so I have created I have read in my control terminology. I can quickly go through this data set. Okay, so this data set, like has little bit additional information than you normally see, but actually we are planning to like reformat this data structure, this data set to Pinnacle 21 spec like format. Okay, so that will be available in version 0.2. In version 0.1, we thought this is helpful, but we already got some feedback from the users that it will be helpful to have it in the Pinnacle 21 format. And I see there is a question here, where does the control terminology CSV file come from? Is that something that EDC can produce? So EDC cannot produce this. So in your current STTM solution, whatever you have, so if it is an Excel file, the statistical programmers or the STTM programmers create that by referencing EDC, your external data transfer specification, and the CDIS control terminology. Okay, that's the standard practice that we follow to create the control terminology file. It's just a structure, how it is different for work, but the content is the same. Okay, so you have the code list code that explains the code list code from CDISC, and the term code also comes from the CDISC, and the term value is the value that we submit that comes from the CDISC. The collection value is the one that comes from your EDC system or your external data source. And then the term, preferred term, turn, synonyms, or other ways that the same data can come in. Like in the SAS world, you can compare this to SAS formats. Like if you collect yes, your yes no value can be like yes uppercase, yes lowercase, y, like it can be in like different formats. In the same way, the capsule, the EDC system can give a value capsule or capsule dosage form or cap. Okay, so if you get any of these three values, you map it to the standard value as capsule. That's what it means. Okay, so based on your EDC system or your data, you have to prepare this file. And at least from my experience, it's possible to do it because we already do that for STTM spec creation. Okay, so we have done with our first step, and the second step is we will read in our raw data. Okay, so I am reading in my raw data. And like the raw data, I have my patient number, site name, instance, and then all the values that we are collecting. So that is like the all these column names correspond to the CDAS standards. So you have yes, no, you have your treatment, what is the indication for which you gave that medication, and what is the dose unit, and what is the formulation, how frequent are you taking, and what is the route of medication, and when did it start, is it ongoing or has it already ended? Okay. So all these columns are here, and you can already see that like you have some unknown values here, right? So my date has unknown, like date and day and month is unknown, and my year is 2019. So this is like a test data. The like the date may not make sense, so but like it but it's okay, it's okay, it's not like as clean as you will see in your actual study, but for the purpose of this exercises, I think this is well and good. Okay. And you can see here, like for example, for this treatment my indication is blank, and for this treatment I have the indication on. So as we program along, we can see how we are able to populate these qualifiers for the corresponding topic variables, right? So this is the topic variable. Everything on the right of it is the qualifier that defines additional information about this topic variable. We can see how it goes. All right, so now I am adding like blank values are being converted to NA. So this is a standard admiral function that we use. Okay, and the next step is I am creating oak ID vars. Okay, I use a function to add the ID vars to my raw data set. So what are the ID vars? So I am adding like three variables here. Okay. So now after I run this function and I close and I open this data set again, and you only give the first three columns or ID variables, right? So work ID is nothing but the row number of the data set. So you have like 14 rows in my raw data set. I just use that as work ID. And the raw source, I have even the raw name of the raw source as CM underscore raw. And the patient underscore number is 375 that is populated from Patna. The reason we do that is, like the raw sources actually will help us in many ways as we start working with multiple data sets. Okay. And this work ID also the same thing. The row number is the key component. We just put it as a column for us to refer that easily. And the patient number in different EDC system reports patient number in different ways. So we just harmonize everything and put that into a common column called called patient underscore number. All right, so then I read in my DM domain, okay, and then I convert the values to NA. So my DM domain has pre-created DM domain for the same subject and all the reference state populated. And as I said, the reference state may not make sense. It's not following any chronological order, and it is like a made-up data. All right, so I think we can start with our first section here, the CM domain. So before I start here, I'll take a quick 2 minutes pause to drink some water, and I'll be back soon. I hope everyone is able to see my screen again. Yeah. So initially we thought, we one of our previous slides. So we saw that, like we first start with the mapping of the topic variable. Okay. So we do the same thing here. So we start with the topic variable, and the topic variable here is CMTRT, right? And CMTRT is mapped from my raw variable called it.cmtrt. Okay. And this is like simple A equals B, and there are no control terminology associated to it. Okay. So I'm going to just select it, the first line here, and I'm going to run that section. Okay. So I have a CM domain with 4 variables, right? So where are the other 3 variables coming from? Let's check it out. So the other three variables are the work ID variables, right? So we preserve that because we use that for merging the qualifiers to it. Okay. So that's how sdtm.work know what are all the qualifiers are collected for this treatment baby aspirin. Okay, and that depends on this work ID and raw source and patient number. These three variables are used to merge as you add on qualifiers. These three variables are used to merge. So now we see like 14 records here. We'll quickly compare it with what we have in our CM raw. Okay, so my first OKD has the treatment as baby aspirin. That's correct. Let me randomly pick another one and check it. My seventh OKD does not have any value for CMTRT, so it should be blank. And my seventh OKD is blank. So this we can remove this record. It's not needed. So when you have topic variable, when you don't have any topic variable, there is nothing to map on top of it, right? So that's how like it. But we can remove this record at a later stage. So let me go to my next step. Okay, so my next step is CM indication, right? That's what I have in my ECRF. If I go back to my ECRF, I finished mapping of CMTRT and I am going to the indication. But indication also does not have any control terminology associated to it. But here I have an additional parameter here. Okay. So what this tells you, ID bars. Okay. So I am using assign OCT function. So here I'm giving only three variables. So my ID bars is an optional variable, optional parameter, sorry, optional parameter. So I am asking sdtm.oak to derive my target variable indication from my raw data set CM raw and my raw variable it.cmindc and create the target variable indc and merge it to the outcome of this step based on the OKD bars. That's what I mean. So I choose these two steps and I run the code. And Ola, I have like 5 variables created in the CM domain. Let me open it again. Okay. So now we see that CM indication value, indication column created, and you see that, okay, first value is blank. Is my indication blank for my first OKD? We can go back and check in our raw data. Yes, for my first OKD, the indication is blank. Okay, so it is able to figure out this based on the work ID vars. So that's why, like we want to, unconventionally, we are actually creating the ID vars at the source first before doing any kind of data mapping. And then we randomly check for another thing. Okay, for this hydrochloride, whatever that is, my indication is leg pain. Okay, let's go and check the converts domain. Okay, for hydrochloride, I'll just keep it to this, and my indication is mapped as leg pain. Yeah, so I think from a quick sampling, so my the values are getting populated correctly, and now you have seen the use of the work AD vars, how useful it is to map the qualifiers to the topic variable. And next, we will go with the adding a condition here. Okay, so my next mapping here is dose. Okay, so my dose, if the dose is numeric, then I am mapping it to CM dose. If it is character, then I am mapping it to CM dose text. We'll just look at this. Okay, so if numeric, then map it to CM dose. So how do I add this condition, right? So I am adding the condition to my raw data set here. Okay, so if I add my condition to the raw data set, okay, so my condition add function, okay, you can actually like click question mark and condition add here. It's going to open the documentation for condition add here. Okay, so my condition add expects like all these parameters. Okay, a data set, a conditions to add, and another data set, and the value, and I have examples here. Okay, so here I am passing the CM underscore raw data set as the input data set, and this is the condition I want to check. Okay, and then I want to apply this condition on this particular variable, right? And if this condition passes, this is going to give true. If the condition fails, this is going to give false. Okay, so let me just copy this code and run it in the console and see how it works. It's going to add additional metadata to to uh, to tell which record is true and which record is false. Okay, I'll run this here. Okay, I need one more bracket. Okay, cool. So if you see here, like this is the metadata that the condition add function is adding to the raw data set. The first is true, second is true, and third is false. Why third is false? You can see for the first record you have a numeric value, and the second record you have a numeric value, and the third record it is blank. So it is not numeric, so it is false. And let's look at this line. Okay, so this line has the cm.txt as 1, that is not numeric, and for this it should be false here. Yeah, it is false, right? So now I have added a condition to my raw data set. Now I exactly know which raw data set has true and which raw data set has false based on the condition that I have applied to check if the value is numeric. And if you figure out how this came from, yeah, I use ChatGPT. No, there is no way I can write this thing. So I asked ChatGPT how to check if the value in a variable is numeric. It gave me some code. I tested it and it worked. It works amazing. Okay. So I am adding this condition to my raw data set. And if the condition passes on this variable, I'm going to create my target variable as cm_dose, and I am going to merge it back with the previous step based on OKD vars. So I am going to go here and I'm going to select this code and run it. And now let's review the output. Let's see how it looks. Okay. So we already saw that, for the 7th, for my CMTRT vomit and my CMTRT hydrochloride. So I have text values. For rest everything, I have numeric values or blank values. Let's check that if it has done it correctly. Okay. So if I go back to CM domain, and here for my CMTRT vomit, my CM dose is not populated, and my CMTRT here, my CM dose is not populated, and for all other places, like I have the numeric value populated. So it is as simple as that. Okay, so you can actually take it apart and program this using dplyr in multiple steps, right? So if you do that in multiple steps, it's still achievable. But what in sdtm.oak we have created these tools so that you can combine all these steps into one step where you are able to apply a filter condition and then perform a mapping and also add it to your STTM output at the same time. So you are accomplishing like 6 different steps that you can achieve in dplyr just with one function call. So that's the benefit of using dplyr, and it is simple and it is easier to read. And as people start using it, your code will be in a similar format across many studies where anyone can read it and understand it and quickly understand what this is doing. Okay, so the same thing is the next one is I am going to do this mapping here, if character then dose txt, right? So for that I have another if condition to check if it is a character variable. Let's run this, hope this is correct. All right, so if I run it, the metadata changes here. Okay, and if you see everything is false here, and you have true only for 2 lines. So for this one it is true, and for the second line it is true, and for all other lines your metadata is false. That's how the condition is being evaluated. So that means my condition add is working as expected. So now I am ready to apply this mapping, and I am ready to map cm_dose_txt to my CM domain and merge it based on the OKD vars. So I'm going to select it here, all the way to the top and run it. And my CM domain now has 7 variables. Yeah, so if you see, you have only 2 records populated here, 1 and 2. That's perfect. Okay, so now we have seen like algorithms that are programmed as function in action, right? So we have reviewed assign no CT algorithm or function, and we also reviewed condition add function. So I think we still have few more minutes. I'll go through a few other functions here. Okay, I'll just yeah, the next one is assigning control terminology. Okay, so next what I want to map is the dose U. Okay, so the dose U has, obviously it's a unit. It has code list associated with it. So what I am doing here, okay, so my parameters change. Okay, so I see that I need to pass the control terminology object, and I need to tell what code list I am using from that object. Okay, so I'm using C71620. So if you go and filter here for C71620, so you have these pre-populated values here, and I have preferred terms and I have synonyms and everything. Okay. So so what happens if you have a value, if your collected value has something that is not represented in this list? So then your sdtm.oak will send a message telling that, okay, so you have a non-standard value in for a standard STTM variable controlled by your cdisk. It could be a real thing because it could be an extensible code list where you want to add some non-standard values, but it will just give you that information for your give that information for you to take a look and make any adjustments as needed. Or if you intend to submit a non-standard cdisk value, you can just ignore that. Okay. So that's the advantage. And also this function will take care of values that comes in any of these formats, any of these values, and it converts that to percentage. It can percentage can be percentage or spelled out as percentage in your raw data. It will still map that as percentage in your target STTM variable. So let's see this example, if we have an example to demonstrate that. Okay, so I have, I think mg gram maybe. Yeah, so gram, right? So gram can be G or gram. Okay, so I have this gram here, and I want, let's see after we run that function if that is changed to G, and it is being represented as the standard submission value. All right, so let me run this function all the way up to the top. Okay, let me open the raw data set and we see the dose U is populated. Okay, let's check out that gram thing. So this gram is, so you have 2 records here. Okay, for CMTRT cortiforin, I have gram, and for amitriptyline, I have G. Let's see if these 2 things have the correct value populated. Both should have G. See, so for corticovin I have G, and also for amitriptyline also I have G. Right. So that's how, like, this control terminology comes in handy. This is like very common in the SaaS world, where where you populate where you use like SaaS formats to convert that into like a standard STTM variable. Okay. So we have 3 algorithms. I will just go through one additional algorithm here and show you the assigned datetime, and then we can move on to the break, and then we can move on to the next domain. Okay. So I'm directly going to the assign datetime function. Okay. So assign datetime function is like CM start date. The target variable is CM stdtc, and I'm using the raw format as dmy, and unknown values as un and unk. So we have like programmed a lot of formats. Okay, so you can actually take a look at all the predefined formats we have in the package. So it's well documented. Actually, I think we have a separate article to do that. So if I go back to my site, so like converting dates and times to ISO format, there's a whole article about how to tell Oak what kind of data format we are expecting. So you can use just like YMD and HMS, and let's say that you have more than one format of your data. You can still, when there's a format variation, you will be able to explain that too as list. Probably I'll see. Yeah. So when you have values coming at y hyphen m hyphen d, or y space m space d, or y slash m slash d, you will still be able to represent all these things. Okay. And populate it here. And if you see the example, you have examples for all these things, and the function will be able to tackle it and convert that into ISO 8601 format. So in our case, we let's stick with the simple one. Okay. Um, I am using DMY, and I have my unknown as U1 and U1. Okay, let's look at our raw data here. And it's DMY, and I have unknowns represent as U1 and U1. I think we are good. So let's run until here, okay, and see how my values are getting converted to ISO format. All right, so I have my CM domain here. Yeah, so you see, for the ones where you are where you have your year, you just where you have your unknown and unknown for day and month, you just have the year populated. And like the fill in the blanks, if you have something weird where you have a year and day known and month is unknown, it, as recommended by CDISC, we populate that with hyphen hyphen hyphen. Okay, so that's one more example I can show you. Okay, so if there are problems in your raw data set, right? So you can run that by running something. Okay, so I am going to create my end date now and show you. And this end date has some problems. I already know that, and I'll show you what it is. Okay, so I created it, and then you get a warning message here. Okay, so there are 5 parsing problems. Run problems to on the parsed results to see what it is. Let's see what the problems are. Problems. Okay, in my CM, and my problem is in derivation of CME and DTC. Let's see what the problems are. Okay, so it says that, okay, so in my work ID 12457, I have blank values. Okay, so that's the problem that it is detecting, but it can actually detect a lot of other problems too. So if your date is not in the specified format, then it can do. Okay, so now let's just like change this to format Y, and let's see what happens. Okay, there are 14 problems now. Let's see what those problems are. Okay, see, it tells you all these like date values that are not in the format that we specified. The format should be DMY, but we said that we are expecting only Y, and like it's telling you, okay, the format is not accurate. So now that's an indication for you to check um, to check um, to check these messages and correct your format accordingly. All right, so that's all about it. And then I will finish the CM domain. Okay, so now that I have derived all the way to the end date, if you remember, end date is the last mapping that we wanted to do here. So we have done it. Now we are doing the variables, the qualifiers that are common for all the topic variables that you are doing your study ID, domain, category, use subject ID, and you are deriving your sequence number, and you are deriving your study day for end date and study day for start date, and then you are just selecting all the values that you need for for your domain. I'll just do this, and then I'll just like click run to create the final STTM domain. So everything is done here, and I have my domain here, nice and ready. It's good to go. It's nicely arranged, and you have all the topic variables and qualifiers populated as needed. All right, that comes to the end of our first session of CM domain. I know we are a little bit behind the schedule, but I think we can definitely catch up as we start the next session. So I'll give a 5-minute break, and we can resume in 5 minutes. So the time is 10:13 now. That's Pacific time, and in Eastern time it should be 11, 12, 1:13, right? So we will resume at 1:18 p.m. Eastern time. All right. So we are at 10:18 Pacific time. I know it's like very late for some users in India, but I see a lot of people still sticking around. Thank you guys. And I see one question from Sumit. Um, Regarding why we need the work area vars. So, so we are looking at the simplest of all examples where you have one record in CM domain where you need to do it. So you can actually use it without, you can map this particular raw data set without the work area vars. But in the next example, we'll have vital signs where you will see the need of the work area vars. And even here, we used work area vars to populate the corresponding qualifiers for the topic variable. So that's where it comes handy. But as you learn more about it, you will know. All right, let me share my screen and get started here again. Try to wrap up this in the next 45 minutes. I hope you are able to see my screen. If not, yeah, please post it in the chat. All right, so going on to that, what did we do here? We run the code walkthrough and we explained it, and we did review the function call for various algorithms, and we did review the assign datum function. We did see how condition add works, and we did see the STTM derived variables. Okay, so now we are at the quiz one. Okay, so everybody, please post your answers in the chat. I'll wait for like few seconds for the answers to pour in, and then I'll show what the correct answer is. And the question is, what function should be used for mapping CM root? Is it assign CT, assign no CT, or assign CT? And when you give your response, I would appreciate if you can also give your reasoning for that. Wow, amazing. I see amazing results. So yeah, I'm glad that I prepared the slides and that people are able to follow. That's great. And the right answer is, as everybody states, we need to use the code list associated. CM root is the target STTM variable, and it has a code list associated with it. So we have to use assign CT. So if there is no code list, you can use as a assign no CT. But since this has a code list, we have to use it. That's great job, everybody. So everybody's with us. So now we can move to the next one of, okay, we wanted to have 10 minutes break, but yeah, but we ended up having 5 minutes. Don't expect another break now. Okay. So let's start the vital signs domain. Okay, so yeah, so vital signs domain, let's again start with the ECRF here. Okay. So I'm going to bring you the ECRF, and this is a non-C dash form. Okay, I randomly designed this ECRF and added value, and I saw some chat messages where non-medically relevant data is there. Yeah, that's my ignorance. I apologize. So I just put some random values to showcase this. It's not medically relevant. You might see a blood pressure of 999 while we go through the next example. Okay, don't get surprised. So so the ECRF is simple. Like you starts with where vital signs performed with yes no, and it is mapped to the VS test code VS all. And when it is yes, then you are populating VS status not done. Okay, and then date vital signs performed, you have a different variable for date, and you have a different variable for time. So VTLD and VTLTM, and this is date part of VSDTC, and this is time part of VSDTC, and we are collecting the time point. The raw variable name is TMPTC, and it is mapped to VSTPT. The time point values are pre-dose and post-dose. And then the position of the subject, and the position of the subject is applicable to only these three topic variables: systolic blood pressure, diastolic blood pressure, and pulse. Okay, so we have the mapping as VS pos where VS test KD equals sys BP, VS pos where VS test KD equals dia-BP, and VS pos where VS test CD equals pulse. And then the next step is the systolic blood pressure. The raw variable name is sys_BP, and you have a text box to enter the value, and you have a hard-coded unit on the ECRF. It means that the site should enter the values in the unit specified on the ECRF. And here you map the collected value to ORS, and the test code is sysBP, and also we need to map the test. I did not specify it here, but that goes without saying. For every test code you need test, and then you have a hard-coded unit MMHG that is also here. And the same thing with diastolic blood pressure, pulse, and going on to the next page, respiratory rate, temperature, and then location of temperature measurement. And this location is applicable only to the test code temperature. Okay, and I believe there was a location in the first page too, but that's position. Okay, that's yeah, position, and this is location. Good. And then we actually have here good example. So this location is only for temperature, and this location is only for oxygen saturation. So you have like the same qualifier, but the value is different based on your test code, and it comes in different columns. Let's see how we are able to handle all these scenarios using sdtm.oak. And like if you compare this to our previous example, CM domain, you went from one topic variable to multiple topic variables, right? So how many topic variables do we even have here? So we have oxygen saturation 1, temperature 2, respiratory rate 3, pulse 4, diastolic blood pressure 5, systolic blood pressure 6, and then the seventh one is there is one for VSR. Okay, there are like 7 topic variables here. And if you look at how the qualifiers are related to the topic variables, right? VSDTC is applicable to all 7 topic variables. Okay, but this and VSTPT is applicable to all 7 topic variables. But here, VS position that we collect in subpos is applicable to only these 3 topic variables. And this unit, hard-coded unit, is applicable only to sysBP. And this hard-coded unit is applicable only to dia-BP. And this ORSU is applicable only to this pulse. So how are we going to handle all these things, right? So this is we are going from a simple example to a little bit complicated example. I wouldn't call vital signs as a complicated example, complicated ECRF, but a little bit more advanced for us to understand how this entire thing works. So let's jump into the code and start reviewing it. Okay, so I'm going to close all these things related to CM. I'm going to close this, and I'm going to clear my session. Okay. And then I'm going to restart it again. I'm just going to run through these steps. And before I do that, maybe it's worthwhile to go back and show just one slide. Yeah, okay. So in the previous example, we had one topic and we have rest of the variables. So we did not have to repeat map topic and map rest. So here we have 7 topic variables, and the qualifiers for each question for each topic variables is different. So you have map topic and map rest for every topic variable that is different. So we are going to repeat the map topic and map rest for each of the topic variables, and then create the qualifiers that are common for all the topic variables. And then adding labels and attributes is not yet programmed. That will come in the subsequent release. So this is a good example for us to see how we are going to repeat this section and how we are going to put everything together again. Okay. So not this session here. Okay, so let me just go through the code here. Okay. I'll run the initial steps that I already explained in the previous one. Okay, so I am going to run all the way until here. Okay, so I'm going to show you the raw data set here. So my raw data set has like two patients, 375 and 376. And the visit name is visit one screening. Okay, two visits here for each patient. And one assessment not done, no. And then your rest everything is there. And then, like you have, like systolic, diastolic, pulse, respiration, temperature log, saturation, laterality, and location. So all these variables are there. So in the SAS world, what you do is you take it, you transpose this data set, and then you map, one topic variable at a time. We are going to do something similar here, but without using transposing and other stuff. So let's look at our code, okay? So first, like I see the section here, map sysbp and its qualifiers, okay? I go all the way to the end, and then map diabp and its qualifiers, and go all the way to the end, pulse and its qualifiers. I repeat the same thing again and again, okay? So for all the 7 topic variables I have, and then like combine all topic variables into a single wave data frame. So 1 2 3 4, all sevens like sysbp, diabp, pulse, respiration, temperature, and oxygen saturation. So everything is combined to one data frame, and then we are mapping the qualifiers that are common to all topic variables, like adding like vsdtc, vstpt, tpt num, visit, visit num, and then study ID, domain, VSCAT, subject ID, and we are deriving the sequence number, study day, and we are putting all this, and we are just selecting all the STTM variables that we need. So it's a long line, it's like 430 lines of code, okay? But like when you use Copilot, it works amazing, okay? So if you type in this comment, it is actually able to generate this code. Sometimes it even changes the code list code value based on the target variable we choose. So it knows a lot of information. So in the subsequent releases, as I saw in one of the chat, we will see like how we can leverage that the Copilot and generate some code that will be helpful for the users. So let's start with the topic variable. So time is 10:31. So I'll go with the demo for like 20 minutes or so, or maybe like 15 minutes. And then like we have like a few more slides to finish, and we'll wrap it up at 11 o'clock. Okay. So now like we are starting with a new variable, new mapping algorithm called hard code CT. So why we have to use hard code CT for BS test code as sysbp? Okay. So if I go back to my ECRF, right? So what are we collecting here? So we are collecting only the value of systolic blood pressure. We are not collecting. Um, we are not collecting with the what is the test code as, right? So then in this case, you have to hard code your test code as syspp because it's not coming on the ECRF. So that's why you are using a hard code function. And then you use hard code CT because it has a control terminology associated to it. So if I open and if I look like C66741, if I open my object here and filter for 66741, so I have, yeah, syspp here that can be represented in multiple ways, but we are hard coding that directly to syspp. All right, so let me start here, okay? And then probably I'll run the first 2 lines, okay? So here I do it like this. So then, so technically I am filtering out all the records that we don't need it. And then open the ESSVP, you have like 5 observations with the oak IDs listed here. And the 4th record does not have any value. So we are just removing it, okay? And then my second thing is I need to add test code. And my test code value is systolic blood pressure. And I use a code list code here. And you can ask me, okay, why do we need to use hard code CT? Can I not just use the mutate statement? Yeah, you can use mutate statement. But like if you leave a typo here, our functions will identify that, and will tell you, okay, so your test is not part of your study control terminology. So you may have to correct it, right? So these are like some additional advantages by using the sdtm.oak functionalities instead of like directly just using dplyr and mapping it. But internally, at least internally, we are using dplyr. Right? So inside this, all these additional things, and at the end of the day, we use dplyr at the end. So I'll open the data set again, and I see that systolic blood pressure is populated for this, for all the values. And then my next one is ORS. Okay, so my ORS is populated the from the variable that we collected as sysbp. Okay, and then I am populating ORSU. Okay. And again, ORSU here, ORS, if you see, like ORS is assigned CT because the value is entered by the site, and ORSU is a unit that is hard coded. If you see here, I'm using assign no CT function here and hard code CT function here for mapping my my control terminology and my original result. So let's look at the raw data here. And and if you look at the raw data, so you have this systolic blood pressure here, and the unit is not in the raw data set. So that's being hard coded. So I go and run these 2 lines of code. Okay. And then if you look at the result, yeah. So I have the original result and the units populated here correctly. And then I go back here, and the last one qualifier that I need to populate is the position, right? The position here, the sub position is populated for vs.vspos when vs test code equals sbp. Good. So again, I am using, this is assigned CT. This value is collected on the ECRF. So, and the control terminology has to be applied. So I am using the assigned CT algorithm, and I merge with the OKD vars, and then it nicely puts together here. So I can actually run like this. That finishes my topic variable and its qualifiers just for the systolic blood pressure. And if you see, for my 6th OKD, the VS pos is blank. Let's go and check if that is the right thing. Okay. So my 6th OKD, that's the last record on this data set. My position is blank. Yeah, the site has not entered the value for position and it is blank, right? So yeah, so then how do I know that? How does sdtm.oak know that, okay, for this OKD is prone and this is blank? And this answers one of the question that was in the chat. This is where the OKD vars comes in handy. So based on this record number and the patient number, I am able to find out that, okay, for this particular record it is blank, and this belongs to the OKD 5, and this belongs to OKD 3, 2, and 1 accordingly. So that's how it's being merged and put together, and then I have this function called here. Right. So the same logic is repeated for the other topic variables. I am going to execute. I'm not going to walk you through because I don't think there is any special things here. So I'll just, yeah, it's just say repeated function calls of assign CT and assign no CT. I'm going to create dia-BP here, and dia-BP is again created with 5 records and 8 columns. And again, position is blank here, and the test code ORSU and position is populated correctly. Okay, and I'll repeat that for pulse. Yeah, and again pulse for no special scenarios. Okay, even for pulse it's repeated. Yep, same thing here. I'll just close all these data sets. Okay. And then for respiration, there is nothing specific here. For respiratory, it's the same thing. And then again, I think for temperature, it's the same thing, I believe. There are no special scenarios here. Yeah, assign test code, test ORS U, that's hard coded, and location that is mapped for temperature. Yeah, so if you see here, going back to the ACRF. So for temperature, we are already in our second page. For the temperature, you see this location of temperature measurement is applicable only for this. Okay, and without writing even any special if else condition, we are able to do it because we are assigning this qualifier when you are deriving this topic variable, right? The temperature topic variable. So it doesn't get assigned to anything else. So I run it fully here, and then you have this temperature, location populated, test code, test ORS unit, and location populated. And the next one is going to be even more exciting. Oxygen saturation has like two additional qualifiers. Okay, so you have ORS unit hard coded as percentage, and laterality that's collected, and location that's collected. Okay, so if we look at the code here, you are creating VS test code using hard code and VS test using hard code, and then you are assigning the value that is collected for ORS, and ORS you again it's hard coded, and then laterality is assigned CT, and then you are applying control terminology, and location you are using assign CT and applying control terminology, and everything is put together by OKD bars. All right, so let's look at the oxygen saturation here. Yeah, test code, test ORS, ORSU, laterality, and location, amazing. So now I have, and then I think one last thing, that is like if the the VS test equals VS, all right, if yes, so that involves a condition here. Okay, so the condition here is, okay, so condition add equals vital signs raw and assessment not done equals yes. So I am adding the condition here. Let's run this condition and see what happens. Right, I think it will be applicable for only one record, I believe. Okay, so here if you see only for one line it is true, where you have that as assessment not done as yes, assessment not done as yes, that is true, and for all other records it is false. Okay, so for then for this, like it should populate it correctly. Let's run it all together and see what happens. Okay, there should be only one record. Yeah, I got one record here, and the only thing I populate is VS all and VS stat, and I have saved VS stat as an exercise for us to finish. But yeah, we are running out of time, so we are not going to do that exercise today. So if not, like I have one more mapping VS stat equals not done that we need to add here. Okay, so now I have finished deriving all these topic variables. I see I have all my 7 data sets here, one representing each topic variable. I just put everything together as VS combined. That creates my combined data set that has like 31 records and 10 variables. Now I can do, like the date and time derivation, right? So now when I do my date and time derivation, like now if you see here, so I have two records here. Okay, so from date and time, both are mapped to VSDTC, and then I am able to specify the format for the date and the format for the time. Let's look at our raw data sets here. Yeah, so data sets like hours and minutes and day, month, year. Okay, so I have specified it here. So I hope it works. Okay, so let's see if you're able to derive the date and time correctly. And there is one problem, and that one problem is a bug here. It is like the NA values are reported as problems now that we are trying to fix it. Okay, so now let's look at the domain here, and then yeah, VSDTC has the date and time populated nicely across all records. And there are no unknowns here. Okay, so in date and time. So the next mapping, we are mapping actually qualifiers that are common to all topic variables. That's like time point number, visit name. And then I am just mutating my study ID, domain, category, and use subject ID, and deriving sequence number, and deriving study day, and putting everything together. Okay, so I'll just run all these things. So that creates my final VS domain that has like 31 records and 18 variables. So your study ID domain, and you can see how nicely we are able to populate the qualifiers that corresponding to the particular topic variables uh, in a nice and harmonized way. And you can see visit day is like 3000 days or something like that. And that's like the problem with the test data that we have. Okay, good. That's the end of the CM domain. And let's go back to the slides and let's wrap up the session. So just go to, okay. So what did we do here? So we reviewed mapping one topic variable and its qualifiers, and mapping qualifiers that are common to all topic variables. And we also saw the usage of vocabulary wars. Okay. All right, it's time for our next quiz. Okay, yeah. So please, the same as last time. Post your answers in the chat, and we can discuss it. When to use hard code mapping algorithm to assign a collected value on the ECRF to hard code a STTM variable that was not directly collected on the ECRF. Yeah, please start pouring in your answers. Amazing, guys. There are so many people giving the right answers. That's amazing. Yeah. Thank you, everybody. Yep. So what is the correct answer? Yeah. To hard code a value that we have not collected on the ECRF, we use hard code algorithms. And to assign the value that we are collected on the ECRF, we use assign algorithms. It's as simple as that. It's no rocket science. As I said, actually, the challenge here is not with the complexity of the derivation, but it is the complexity of the incoming raw data. Okay, so hopefully, and the data standards we use. So hopefully with these versatile features of sdtm.oak, where we are able to specify the raw data set name, variable name, target data set name, target variable name, we are able to alleviate that challenge. If you look at the code here, right? So every function call has these four parameters listed, okay, clearly: raw data set variable, target variable, okay, and data set variable, target variable. So that's how, like, we made it like versatile enough to accommodate any raw data structure. As long as you have this vitals raw and these variables exist in your raw data set, sdtm.can create the VSDTC based uh, based on the algorithm that you use, right? So let's go to the last session of today. Okay, so release summary, we have version 0.1. What can we do with that, right? We can do some, but we are also not supporting some features. Let's see what we are supporting and not supporting. Users can create a majority of STTM domains. Okay, that's like that is not associated to your metadata that you have in your company, like central labs, local labs, QRS, those types of things. Other than that, so all of the data sets can be programmed. What are we not supporting, right? So we are not supporting demographics, exposure, trial design domains, subject visits, subject elements, rel-rec, associated person domains, and creation of epoch domain and the epoch variable across all domains. So these are all not supported at this time, but eventually as we go, like in version 0.2, 0.3, 0.4, we will be developing these features and we have a long way to go. Yeah. So how can we automate it? Okay, so now I saw some comments. Okay, how can we skip typing these repetitive code? So there are two ways, like we are thinking about automation. So one is the way that Roche implemented it, and the other one is the way is to use LLMs. So we are still exploring. So we don't know how to proceed, but I know for a fact that the way that Roche has implemented will definitely work. Okay, that is based on a standard STTM specification. Okay, I'm going to show you a standard STTM specification, and I think I already have it open, and it's already part of the package. like if you guys want to explore at your leisure. So we have the standard specifications here, okay, and it's on the specs folder. So I'll for the simplicity, I'll open that in Excel and I will show you. So I'm going to bring the vital sign specification to the screen, okay. So this is my vital sign specification, and you have like lot of columns here, okay. So you have raw data set, variable, label, and then so many columns here. So I'll just showcase one. Okay, so let's filter for systolic blood pressure. Okay, so systolic blood pressure, if you remember, so we had like I think we had like 4 mappings. I mean, very specific to this, right? So let's see how we can automate it. So it's like the raw variable name is systolic blood pressure, label is this, and what is the variable type text. Maybe this information we don't need it, I don't know. We have just kept in the specification now. So my first mapping, let's go here. Okay. So I need to map these 4 variables, right? Test code, test, original result, and unit. And 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 then I can specify what algorithm I need to use. Okay. So for assign no CT for the result and hard code CT for the rest. So if I am using hard code CT, I need additional parameters like what value I am going to hard code, right? So I am going to hard code as sys-BP, systolic blood pressure, mmHg, and what is the code list code and the term code we are going to use. This is the term code, and the code list code is already there in the specification in the previous section. Code list code is here. So if you look back to this function call, right? If I go to systolic blood pressure, if I look back to this function call, I have everything I need to make this function call in that specification, right? And that specification can be created based on the metadata that you have in your company. Like you can have like any format of Excel specification, but you can extract the values from the Excel specification and you can put it in that template that we have created. And you can write a program that fits for your company needs to populate that particular template. Once that template is populated, reading that line by line and making this recursive function call is very easy. So like instead of like 400 lines of code, you can just, if you have your specification and tell that, here you go, create domain function call, here is your specification, here is your raw data, here is your control terminology, and it can read the specification and it can make these recursive function calls and it can create your STTM domain. So this is something that we will be working on in the upcoming releases. Okay. And then let's look at another example where I have to use condition, right? So if you remember for this mapping, we had a condition that we need to apply. Okay. So my lunch condition is, so if no, then I need to map this. And if no, then I need to map the test code and then test. And then if it is yes, I don't have to do anything. So I have these 3 mappings, and like I can actually specify I am using condition add, and also I am using hardcode CT, and I can specify the parameters in the spec. And my condition add can have like a condition add parameter like this. Okay, so I can actually specify the R code itself here, or there are other ways to specify. Okay, what is my condition split across multiple data sets? My condition left data set variable here, and my operator is equal to, and my right condition is this. There are both ways to represent the same metadata. We have not figured out which way to use, but there are ways to do this and then generate the code or make this recursive function call to compute a condition and then perform the mapping. So that's in works. So we'll be working on it in the upcoming releases. Okay. All right. So roadmap. So the next one we want to do is like DM domain. That's because like without DM domain, um, that's the basic we need to use, and that's also the most complicated domain we have. One of the most complicated domain we have with reference state derivations and stuff. And then we'll start looking at the metadata driven automation or standardized SCTM specification, and then we'll provide epoch variable and create functions to derive standard units and results based on the metadata. And this is going to be the most tricky part, because every company is maintaining the metadata as separate in a different format. Let's see how we can do it, and then supplemental domains and stuff. Okay, yeah. So uh, it's a it's a volunteer based work. It's not the work that gives us the first. It's not like our regular day job. So we are spending our free time to create the sdtm.work package, and we have gotten it to a very good starting step. But from here, if you want to move forward and develop all the features we want, we definitely need community engagement. And these slides will be published in our Informa forum, and you have all these ways to reach out to us and and support us. Try give us feedback and also contribute to the development of the sdtm.work package. All right, that's it. Thank you, everybody. And we still have like 6 minutes left. I'll hang around to answer any questions in the chat. I don't know if anybody can, if people can speak and ask questions. So if not, I'll just monitor the chat for the next 6 minutes and answer questions. And thank you so much, Shiu and Edgar, for answering a lot of the questions on the chat. And I thank all the volunteers, Ramiro, Kamil, Mosin, so many people who are like spending their weekends to create and have contributed to the sdtm.work package. And thanks to everybody at this occasion.